and welcome to this Girl Develop It meeting. We hope you all had a great spring break. This will be our last Girl Develop It meeting for this school year. And so today we will be exploring green screen applications. So what are green screens? So green screens are commonly used for editing the background of images and videos. And basically computers recognize the green color and replace it with a second image to superimpose these selected images. And green is typically used as it doesn't match any typical hair color or skin tone. But of course, you could also use different colors. Your code would be slightly different based on that. And here's an example from Harry Potter using green screens. All right, so for this video that we're quickly going to watch, this person will be quickly going over how to code for green screen algorithms. And we'll be watching all the way to 6:51, and then we'll skip to 7:45 for the correct solution.
Okay, now it's time to turn our pseudocode into JavaScript code. For this video, we've already started by filling in some of the code because it is so much like our previous examples, and we figured that you've seen it before, so we don't need to go over it again. So that's creating the FG image, the BG image, and the output image that is the same size as the FG image. So we're going to get down to actually writing the code, which says to process each pixel in the FG image. So we've written our standard for loop that goes through each pixel of FG image.values. So now we're at the first line of pseudocode that is non-standard, that's specific to this problem that we haven't written before. And that is to look at the current pixel and determine if it's green. It turns out that we didn't really figure out what green is in our planning. So we have to kind of figure that out now as we're coding. We intuitively understood it when we were working out our plan, but how do we explain it to a computer? How does a computer know what green is? Right now, we're not sure, so we're going to start very simply. And we're just going to say if the green component of the current pixel equals 255. That's an example that we've seen before, that we understand means that something has a lot of green in it. In fact, it means it has all the green in it. And so that's a simple place to start, and we'll see how it works out as we go. Starting simply is often a good strategy for when you're writing code, just to make sure that we have something that works. With that done, let's start looking at what we're going to write when that condition is true. Then we're going to go inside the conditional and write that code. So it says to look at the same position in the BG image. And we recall that every pixel has a coordinate location within an image given by its X and Y values. So we're going to go ahead and get those and store them in variables named X and Y reasonably. So that is the corresponding location in the FG image, and now we want to get the pixel of the BG image at that same spot. So we'll call get pixel with X and Y to get that value. So now those three lines represent that one line of our pseudocode. So we needed to do a little bit of work to translate that one line into actual code. Now that we have the corresponding pixel in the BG image, we want to set that to the corresponding position in the output image. So we're going to do that by calling set pixel with that X and Y and the BG pixel that we just got. And that completes the inside of that if statement. Okay, let's look at our last line of pseudocode. It starts with the word otherwise. Well, what does otherwise mean? Otherwise means only do this last piece if the condition on line 12 was false. Well, how do we write that code? Well, we could write the opposite or the negative of the condition on line 12, but that can be hard. And so that is error prone, that can lead to problems. So most languages, including JavaScript, include something called an else statement, a shorthand for this situation. And else just means if the condition above on line 12 was false, then run this code instead. So what do we do when we say otherwise? We're going to set the output's corresponding pixel to the current pixel. So we're going to say output dot set pixel X and Y again. But in this case, we want the current pixel. So that's just pixel. Now we wrote X and Y here, and those might be, and those are things that we want to compute just like we did before. And I'm just going to show you a different way to do it than how we did before. I'm going to write these values in line, whereas in the previous version, I wrote them and stored them in a variable. So from a functionality perspective of the code, these work exactly the same. Whether I decide to save it into an instance variable or whether I pass it directly into the function doesn't matter from the programming functionality perspective. So you should use the one that you're most comfortable with. Some people find it more readable to give every value a name, and some people find it more readable if the code is a little bit shorter and they can write them in line. It's entirely up to you what you want to do. But now I'm going to review my pseudocode and see that I start out and I've got for each pixel. That was my standard loop. I'm checking to see if the current pixel is green. Then I'm getting the pixel at the corresponding X and Y coordinates in the BG image. I'm setting those to the corresponding position in the output image. If that wasn't the case, then I'm setting the pixel, the corresponding pixel in the output image to the foreground images or the current pixel. So I feel pretty confident at this point that my pseudocode is correct, or that my code corresponding to my pseudocode is correct. So I'm going to run the code.
Oops. So up to there is the almost correct solution for the project. However, when he runs the code, there's something slightly off. So we're going to skip to 745 for the correct solution.
Ah, that looks a whole lot better. Now I can see dinosaurs. Now I can see space. It seems like it worked a whole lot better to give us this range. However, if you look very closely at the image, you'll see that Drew and I have a halo around us. We have a green halo where we weren't quite correct in our range. So let's try, since that worked so well, let's try upping the range a little bit more and say making it 200. So that gives us even more green values to work with to try to get that halo to go away. And I ran the code again, and now you can see that the colors, the space colors, are bleeding into Drew's shirt. And so it looks like Drew is fading into space, and that's not what we want either. Now, we could spend some time trying to perfect this range for this particular image so that we get the halo to go away, but space doesn't intrude on the foreground image. But that doesn't seem like the best way to go about solving this problem, because we're really just going to make it work for these two images for this particular range of colors. So let's think about a different way to define green that might be a little bit more general and robust. So instead, I'm going to define green as a color that has more green in it than both red and blue combined. So I'm going to write that as green. The value of green is greater than the value of the red and the blue added together combined. So now when I run the code, I see that the halos went away and the space went back to its proper place. So I'm very happy with the results of this code that I've written.
All right, so basically what he did here is that instead of setting green to a specific threshold value, in which case sometimes there was a halo around the person, or sometimes the background bled through, you could say, through the image. Instead, what he did is that he said that the amount of green in a pixel must be greater than the amount of red and blue in a pixel for it to be replaced. And so this got rid of, as he said, the problems with the threshold values. If you really wanted to, you could play around with the threshold values to get the same result, but this is a far more efficient solution to solve that problem. Awesome. So now with that video, you all can attempt to do this mini project on your own. For this specific project, it would probably be best to go to this compiler right here. The link's right here. You could also technically use just like a JavaScript compiler, but the Duke class already has images inbuilt for you to use. And then also if you use that compiler, you can use the exact same code from the video to try it out for yourself. I would encourage you all to just start with the starter code at first and try to code the rest on your own. But if you get stuck, you can always refer back to the video for hints on how to implement green screens. And so since this is the last meeting, this is just a quick recap slide of everything we have covered this year, or a syntax recap. There's all of your HTML code we've learned, your CSS code we've learned, and your JavaScript code that we've learned, as well as some images from the various mini projects that we have done throughout the course of this year. So if you are ever coding in HTML, CSS, or JavaScript and need a refresher, this is definitely the place to go for that. Also, if you want, if you have extra time, you could also attempt these HTML, CSS, and JavaScript Kahoots. These are a great way to review the syntax that we have learned throughout the course of this year, and Kahoots are always just fun to do. Some resources, this is our parent organization website right here. You can look at it for local chapters, and if you're interested in joining, I believe there's also information about joining the official GirlDevelopIt chapter for San Ramon. Our main website is listed right here, and it's also been emailed out to you all. There's a meeting slides collection if you ever need to reference syntax we have learned throughout the course of this year. And if you want to look at any of the previous mini projects that we have done and examples and solutions, you can also visit this link right here. All right, so here's next year's officer board for 22 to 23. Next year, your president will be Serbi, your vice president will be Sneha, and your secretary will be Shika. Congratulations, and we hope that you stay around next year so that you can see these officers and continue to be part of the club as well. With that being said, unfortunately, this is our last meeting of the year. We hope you all had fun learning about HTML, CSS, and JavaScript. If you are not a senior, we hope to see you next year. If you are a senior like me, good luck in college. And yeah, thank you so much for a great year, everyone. And have a great rest of the school year, and we hope you have a great summer vacation as well.